Session 4, Glance Image Management Service for OpenStack. We are doing it for Wallaby. Agenda of this session is architecture and main components of Glance, deploying new image to an OpenStack instance, managing images, managing image backends, and verifying operations of image service. So architecture and components of Glance. OpenStack Glance has a client-server architecture that provides a REST API to the user through which request to the server can be performed. The domain controller, a Glance domain controller, manages the internal server operations that is divided into layers. Specific tasks are implemented by each layer. All the file data, that means image data operations, are performed using Glance store library, which is responsible for interaction with external storage backends or local file system where the image can be stored. Glance store library provides a uniform interface to access the backend stores. It uses a central database, that is Glance DB, that is shared among all components in the system, and it is SQL based by default. This figure explains the concept. When we are talking about Glance, we have Glance database. The interaction happens through REST API. Authorization of all the requests which are made to Glance server are done through Keystone. So a client is authenticated using Keystone and send the request. A Glance store driver of course need any request to be authenticated. So authentication happens through Keystone. The REST API requests this Glance domain controller, the image. So auth, notifier, policy, quota, location, database, all these are different layers. So this is the registry layer, database abstraction layer, where the database is implemented, and Glance store implement the storage of image, various supported storage options like file system, object storage, Swift, then Ceph, and then sheepdog, and multiple depending on the drivers. So Glance store drivers are multiple. This is the main architecture. So the components are, first is a client, starting from top on the left hand side. Any application that makes use of Glance API server or Glance server. REST API is the Glance functionalities are exposed via REST. The database abstraction layer, that is DAL, is an application programming interface that unifies the communication between Glance and the database. Then we have Glance domain controller. It is the middleware that implements the main Glance functionalities such as authorization, notification, policies, and database connections. Then we have Glance store that used to organize interactions between Glance and various data stores. A registry layer, optional layer that is used to organize secure communication between the domain and the domain Glance domain controller, data abstraction layer, by using a separate service. Glance itself does not store images that you have seen in the diagram. It uses plugins for particular storage, for example local file system, Swift or Ceph or NFS or any other backends. Metadata of images are stored in the Glance database, usually as MariaDB instance, and it supports many disk formats. The disk formats supported by Glance are AKI, which is Amazon kernel image, AMI, which is Amazon machine image, ARI, which is Amazon RAM disk image, ISO, which is archive format for a data content of an optimal disk optical disks such as CD-ROM. QCOW2 supported by QEMU, that is quick emulator, that can expand dynamically and supports copy on write concept. This QCOW, by the way, the name also comes from COW. Q stands for QEMU and COW cow stands for copy on write, and that's the name QCOW2. And because it supports copy on write. Raw unstructured disk image format, if you have a file without an extension, it is possibly a raw format. VDI supported by VirtualBox, Oracle VirtualBox, virtual machine monitor, that is VMM, or the hypervisor. So VirtualBox hypervisor or virtual machine monitor, the same term, whether you call it virtual machine monitor or you call it a hypervisor, this is one and the same thing. VirtualBox is type 2 hypervisor which is installed on the top of an existing operating system, and I am demonstrating these examples, this cloud setup, using Oracle VirtualBox only. And the QEMU emulator. VHD is VHD disk format, a common disk format used by virtual machine monitor from VMware, Xen, Microsoft VirtualBox and others. And VMDK supported by many common virtual machine monitors. Virtual machine monitor, as I said, please remember it is the same thing as hypervisor. They are used interchangeably. Check the services on the controller, systemctl grab glance. Let's verify and we'll see some examples what all services are running on our Ubuntu system, and we'll verify that. So this is our controller node, sudo su hyphen, and I can use that systemctl grab glance. So only one service is running which is required for glance minimum work, which is glance API service. Usually when glance service Nova is trying to spawn a new virtual machine, it sends a get request to the URL passed to the glance service images and particular image ID. This is how the request is made. If the glance API finds the requested image, the service will return the URL where the image is located. After that, Nova, the compute service, sends the link to the hypervisor driver, and the hypervisor will download the image directly from the location. Two main configuration files are glance API and glance registry. This is no more needed. So main file configuration file is etc glance api.conf, because these two files contain similar settings. So we work only with the glance api.conf. Default configuration files comes with a huge amount of comments and are a very good source of information. And if you want to see the uncommented line, you can use this regular expression to remove all the comment and make the configuration file shorter. Let's see that. You see api.conf. This is the main file, and these are uncommented sections of this file. So default, sender, course, database. So the main important section is database, where MySQL, PyMySQL, and the URL and the database and everything, password. This is password. This is user ID. This is the database name at controller. Backend, and then another important is backend store. So what all backend default store, what is the default store, what all disk formats are supported, this is what is listed here. If you see AMI, ARI, AKI, VHD, this is same what I explained. And default store is file, means by default images will be stored into the file system. The default stores for me, I configured HTTP and file. So by default, where this images will be stored, the data directory is where live glance images. So glance store have these sections, which is glance store, file system, store data directory, default store, and stores. Then image formats, and then key store auth token, the authentication specific details, very important. password, project name, username, project name, user domain name. This setting you'll find in every service. This is a common for all because authentication details which is to be handled by Keystone will remain same for every configuration, every service we are going to configure, we are going to learn. So if you look at apart from this, there's nothing else. Keystone authentication, which is going to be common, image file format, default store file. These are the details which are configured because this is configured glance on my system. In both configuration file, you can find the database connection. That's what I was talking about. I already explained these sections. Database section where the connection URL is, glance store, and I already explained these syntax, and keystone auth token, the most important. Apart from that, nothing else is what we configured. In our setup, Keystone server has the IP address 10.10.0, 10.0.0.11, and you can see the public identity API endpoint and the admin identity API endpoint definitions. As you can see in the configuration file, the username for Glance service, tenant and password are in clear text format. It is very important to keep in the right permission for all configuration files because many of them contain password in clear text format. Deploying new image to an OpenStack instance. You can download various cloud-ready images from internet. Most major Linux distributions already have prepared images for OpenStack. SirOS is the bare minimum testing image. Ubuntu, Debian, Fedora, CentOS, you can find out the image, and Windows Server 2012 also have this image available. For testing purpose, you can use SirOS image, which is a minimal Linux distro that was designed for testing images on the cloud. So first you need to download it, the image with the wget-p in location temp directory are downloading this image. In a SirOS image, the username of existing account is SirOS and the password is go cubes go. It's not that, it is go cubes go. Go CUBS go. Because this is old image, the new image have this go cubes go password. Then you can deploy the image in the cloud using OpenStack image create. OpenStack image create the file name where you have downloaded the file, disk format qcow2, container format is bare, and hyphen public means this image is going to be public and the name will be SirOS. Here public means the image can be used across projects for every user in OpenStack cloud. To get information about the images, you can use the command OpenStack image show or OpenStack image list. Let's try. I exit from this now and we'll see the functionality. First, I need to source my credentials. Source admin OpenRC, OpenStack, image list. That will show me my images in my cloud. And after I see the image, I can use OpenStack image show and the image ID. I can specify name also, but if we can have multiple images with the same name, in that case they will have different IDs, so we have to use ID in that case. The output will remain the same whether you use this or the image ID. You see that instead of name I'm using the image ID, and you will see the same output. So what you see here in the checksum container format is bare, I created this on 16th of March. Disk format is qcow2, file where it is located, ID of this image, main disk, main RAM, name of the image, owner is this user ID, then properties. So what you see is schema, size, status, active, all these details are kept here in this image. More information about images. As an admin, you can see all images are in the cloud. It's good to know information about image before onboarding it to OpenStack. Use the command kimu img from package with the same name. So kimu img info and the image name. So it will give you information images. See, I have used it in uh, my cloud as normal user, stack user, where the image is located. Let's try. I have these images here, and let me see QEMU. I have this information in IMG info, and I specify the image. This is the latest image you can see here. I downloaded this image. So it will give me the details about the image. Kimu IMG info, image name. So image is this, file format is QCOW2, visual size is 112 MB, disk size is 15 MB only, cluster size is this, file specification information, compact, lazy. So there are so many options. I never even tried. Whether you can find out more information on these options. We never tried all these options. But yes, when you're doing it production level, you may get to know these fields definitely. And I recommend that you study. But I can give you direction here. It's impossible to explain all features and all options. It is possible to create an image in OpenStack in web interface as well. Project, compute images, click on create image. Only the image name, format and files are mandatory, and you will be able to create the image directly from the console also. Managing images with the commands. These are the commands available for glance. OpenStack image create, create or upload an image. OpenStack image delete, delete images. OpenStack image add project, associate project with an image. OpenStack image remove project, disassociate project with an image. List, save an image locally on the disk. Show, display image details. Image set image properties. Associate project with image parameter. Associate project with image positional arguments. Project is image to share, name or ID. If you have multiple images with the same name, which is possible, then you have to use ID. Otherwise, you can use name also. Project is project to associate with image, that is name or ID. Once you have your image set up, you can download it. So OpenStack, image, save, CirOS, and local image name, and then you can see the image. This is what I have demonstrated here. OpenStack, image, save, CirOS, and locally where you want to save it. So it will download the image from the cloud and save it locally on your system. Managing images, adding properties to image. OpenStack, image, set property, architecture equal to ARM hyphen hyphen property. This is a typo here. It should be hyphen hyphen. Property, hypervisor type is Kimu, image name or image OS ID. So here the same thing. If there is multiple images with the same name, you have to use the ID. Otherwise, you can use the name. The image service has predefined namespaces for metadata definition catalog. To load this file from this directory into the database, you can use glance manage database load metadata definitions. Glance manage db upload metadata definitions. Deleting an image, quite simple. OpenStack, image, delete, image name or ID in case you have multiple images with the same name. Debug option. OpenStack command have hyphen hyphen debug option. If you want to see what is behind the CLI, it might be useful for troubleshooting or learning more about the API. OpenStack image list hyphen hyphen debug. Let's try. OpenStack image list hyphen hyphen debug. Wow, it's give huge information. Not only the list, but it gives you actually what is happening behind the screen when you are pulling this. So you can actually find out the errors. Wonderful. Namespaces, access secret, access token endpoint. It gives you complete comprehensive information. Sudo -i cd slash where slash lib slash glance, and here you will find the images. Actually 3D images, the actual images are located here, and this is the image, how the images are stored with the IDs. You can see that these are image IDs, the real location. Image on the disk, you can find files with the name that are equal to the image IDs on the disk under where lib glance images. We have seen just now the same thing. Managing image backends. Glance can support various data store backends such as Swift, Chef, NFS, local file system, and others. You can define each particular backend in Glance store section of this Glance API configuration file. And these were the two lines, if you recollect, we discussed during the configuration setup: store file and store data directory. Of course, then you have to specify and you have to configure the appropriate driver also. And in the corresponding section of the driver, you have to enter the details of the driver as well. You can even have the multiple backends at the same time. In this case, Glance will choose a particular backend depending on the free space and priority. For example, if you have two mounted disks where live Glance images, you can add something like this: file system store directory, mount point A, priority 10, mount point B, priority 20. To limit the size of images, you need to add image size cap parameter and maximum size in bytes to the Glance API configuration file under default image size cap in bytes, and then you need to restart this. On Ubuntu, this is simple Glance API, not OpenStack. It's systemctl restart Glance API. If you need to limit the store amount per user in Glance, you can specify user storage quota and then again restart the service. Let me show you systemctl status glance -api dot service. This is the Glance API service. As I said, it's not OpenStack Glance. In Ubuntu, it is Glance API only. You can check the presence of Glance service in Keystone service catalog also. Source this file and OpenStack service show Glance. That will show you the service details as well. Glance API endpoints. You can also use a OpenStack endpoint show Glance. Let's look at list, and that will show me all the endpoints. When we have more than one, then I have to use grep. Then I have to use a little more different option in that case. That's precisely correct because we have three endpoints: internal, admin, and public. So I have to use the list command and then grep glance. That will show me all the three endpoints. And this is my endpoint: internal, admin, and public. All communications are happening through HTTP. In real life, it can be done through the HTTPS also. URL for admin interface, public interface, and internal interface can also be different. In our case, they are same. Keep in mind that Glance registry is listening on port number 9191, but you will not expose that registry for external services. I never even tried. I never even open this port. And then that is for Windows, or that is for the CentOS machine. Now the log files, troubleshooting. You may also want to check the Glance log files. The logs are located at where log glance api.log. This is in charge of Glance API and registry if you have registry.log for Glance registry service if it is applicable. To adjust how the logs are detailed, you can add an option in the Glance configuration file, API configuration file, where you specify verbose is equal to true and debug is equal to true. This is required when you are troubleshooting Glance. That's all for this session. Thank you very much.